Hello dear friends, it has been a while since I recorded a video about fighting old age. Today we are going to talk about ordinary baking soda, but from the perspective in which fans of unconventional methods of treatment are used to know about baking soda. That is, it will not go into any reductions or increases in pH, as this is really not a scientific concept. And it will be about a new study about a discovery, I would say, which allows us to look at soda in a different way and allows us to understand why we can use this simple remedy to fight age-related changes. Let me remind you that it is currently believed that age-related changes in humans develop due to chronic systemic sluggish inflammatory processes. How does this occur? Over time, as a person grows older, aging cells accumulate. Either this happens as a result of external influences, or as a result of programmed genetic mechanisms, or as a result of some existing circumstances. As a result, the human body accumulates a certain number of cells that do not die, but do not fulfill their functions fully. These aging cells are not only useless ballast for us, but they also produce certain factors that damage nearby cells, making them also age. These factors are called aging factors. A certain critical mass of aging cells accumulates in the organism, and the organism begins to perceive them as foreign. We have cells in our blood called monocytes. Monocytes gradually leave the vascular bed and look for enemies in all organs and tissues. Such monocytes are called macrophages. They are almost everywhere in the liver, in the spleen, in the wall of blood vessels. In the brain, there are special macrophages. In the skin, there are a lot of them in the intestine. In general, everywhere where the immune system is present, macrophages find aging cells and start to activate. They start releasing interleukins. Interleukins are substances that can attract other cells of the immune system to help the macrophages. The most important inflammatory interleukins are tumor necrotic factor alpha, interleukin 1b, and interleukin 6. Through the release of these interleukins, other cells of the immune system flock to the site of the cluster of senescent cells or damaged cells. Neutrophilic leukocytes flock, for example, T lymphocytes flock. They begin to secrete factors that destroy the cells. Eventually, these senescent cells die. As a result of the death of these cells, the body releases substances again that further increase the inflammatory response. Even more macrophages migrate to these sites. Even more macrophages begin to produce even more intensely alpha-TNFs interleukins. As a result, the inflammation continues, and it continues in a vicious cycle mechanism. So the body starts damaging its own tissues. Its own tissues begin to release breakdown products. These decay products again provoke inflammatory processes and so on without end. As a result, a whole series of pathological changes are triggered, which we see developing in old age. So these are neurodegenerative diseases, the same Alzheimer S and Parkinson S. It is cancer as a result of chronic inflammation. This is a lesion of the cardiovascular system in the form of formation from atherosclerotic plaques and aneurysm. This is the deterioration of kidney function. It is inflammation of the joints. It is various arthritis and arthrosis. This is unfortunately the activation of autoimmune processes. Against the background of chronic inflammation, the body begins to perceive some tissues that are their own as alien. And these foreign tissues begin to produce factors that destroy them. According to this principle, begin to develop or manifest, that is, manifest rheumatoid arthritis, disease, Crohn, S disease, non-specific ulcerative colitis, various autoimmune diseases of the nervous system. The fact is that chronic systemic inflammation, among other things, suppress the function of T regulatory cells. T regulatory cells are lymphocytes that inhibit an overactive immune response. If the function of T regulatory cells is impaired, the result is that allergies and autoimmune diseases begin to overwhelm the individual. Thus, chronic systemic inflammation triggers a whole series of pathological changes that sooner or later destroy a person, as health and eventually lead to death. Well, of course, the current efforts of doctors are focused on reducing the phenomenon of chronic systemic inflammation. Well, first of all, it is lifestyle and it is diet. I already have a video about what to eat in order to reduce the processes of chronic inflammation. And by the way, the popular trend right now to reduce carbohydrates is also due to the fact that carbohydrates trigger systemic chronic inflammation in the body. By the way, obesity is also one of the contributors to chronic systemic inflammation because the fat cells that we have on our internal organs, the so-called visceral fat, are a very good place to activate macrophages, which then release pro-inflammatory cytokines. That is why they are now fighting so hard against excessive fat, fighting against carbohydrates, and also developing drugs that block factors of chronic systemic inflammation. First of all, these are drugs against tumor necrotic factor alpha. They are widely used to treat autoimmune diseases, for rheumatoid arthritis, for Bixteru, S disease, for psoriasis, the same Humira, for example. Interleukin blockers are also used. So they also reduce chronic systemic inflammation, and they also treat people with autoimmune diseases. But it turns out to reduce pro-inflammatory cytokines, alpha TNF. Bad interleukins can be reduced by taking simple baking soda. A 2018 paper published in the Journal of Immunology showed that taking 2 grams of baking soda a day helps reduce the inflammatory activity of macrophages and increase the activity of T regulatory cells, which, as you may recall, reduce the activity of autoimmune processes. Macrophages, as a result of soda intake, stop producing pro-inflammatory cytokines. That is, a decrease in the level of alpha TNF, interleukin-6, interleukin-1 beta was clearly shown, and an increase in the activity of T regulatory cells was also shown. All this led to a reduction in the processes of chronic inflammation. Why was this possible? It turns out that when taking baking soda, it is no secret baking soda interacts with hydrochloric acid. The reaction here is very simple. Soda is at 3HCO3 plus hydrochloric acid H-chlorine. The result is a simple salt on 3HCO2, which is carbon dioxide, and H2O, water. And of course, the soda cannot be absorbed unchanged into the blood to the extent that it affects the PASH in any way. Here, in order to shift the PASH seriously when taking baking soda, for example, well, you probably have to drink a pack of baking soda. I'm exaggerating, of course, but actually 16 to 20 grams would probably have to be taken. But when it comes to 2 grams of soda, here, of course, no PASH shifts, even theoretically. But when we're talking about 2 grams of soda, there is no PASH shift in the blood at all. What is happening? This is the reaction you described. The soda reacts with hydrochloric acid and binds both it and hydrogen. The hydrogen ions are positively charged. It is neutralized, turns into water. And cells that line the outside of the stomach, they also line all the internal organs. So if we cut open the stomach and see what the internal organs are covered with, the spleen, the stomach, the intestines, we will see that there is a thin film called peritoneum, and this peritoneum is covered with cells. The cells are called mesothelium. And these mesothelium cells, which are on the stomach, get a charge, they polarize. And the interesting thing is that the mesothelium cells, it turns out, can conduct this charge to other cells. So they conduct that charge to the cells that cover the spleen capsule. As a result, the spleen capsule polarizes and transmits that charge signal to the cells that are in the spleen, the macrophages and the T regulatory cells. Of course, there are many cells in the spleen, but in this case it is the T regulatory cells and macrophages that are of interest to us. Macrophages polarize and change their properties. They go from being inflammatory cells to anti-inflammatory cells, and T regulatory cells begin to simply become activated, and as a result their number and activity increases and they suppress overactive inflammatory processes. The novelty of the work is that showed not only the ability of small amounts of soda to cause anti-inflammatory effect, but it was also shown that mesothelial cells, that is cells lining the abdominal cavity, are able to conduct electrical signals almost as well as the cells of the nervous system. What does that tell us? We can, based on this knowledge, simply take 2 grams of soda in the same way that the participants in this study took it. And they took it this way. They dissolved 2 grams of baking soda in a glass, 250 milliliters of water, and they drank it slowly. It didn't say whether they drank it on an empty stomach or not, but logic suggests that it is probably better to drink it on an empty stomach. So the reaction between hydrochloric acid and soda will happen more quickly. Why do not drink quickly? Because the reaction of soda and hydrochloric acid of the stomach will release acidic gas and simply can bloat strongly stomach, which will eventually lead to unpleasant sensations in the stomach. 2 grams of baking soda in a glass of water, taken gradually on an empty stomach, can seriously help us to overcome chronic systemic inflammation, and therefore also to push back the manifestations of old age, push back the manifestations of diseases that are associated with chronic systemic inflammation. And what we know for sure is that 2 grams of baking soda will not harm us in any way, but at most they may cause a slight discomfort in the stomach. Thank you very much for your attention. Everyone have a great health and good mood.